Good morning, everyone, or good afternoon, depending on where you are. Might even be good night. Welcome to our webinar. This is the third installment in our series about cloud security. We're veering a little bit off the topic of pure cloud today and going to look at container security. So this is a topic that is, kind of intertwined with cloud technologies. You see them often together, although strictly speaking, there is no technical link there, but the topics are very common to be combined. Also when we do testing, and today, together with me is Roy Stultins. He is one of our main security consultants when it comes to the topic of cloud security. As I said, today, the third in the series. Just a quick introduction about Secura. As you probably know, we are a digital security expert company. We perform a lot of tests, inspections, and we also do certification on the topic of cyber security. So our mission is to provide insight into your digital security. So we like to do this by connecting to standards and metrics, and we also think that security is not just a matter of technology, but very much also of people and process. So we have pretty much organized ourselves along the lines of market groups, and we move in the space of not just IT, but also OT, so operational technology, think industrial security, SCADA, ICS, PLCs, that kind of stuff. And of course, a very interesting topic that is also connected to cloud is IoT. Well, you might have heard the news. If not, then since January this year, we have become part of the Bureau Veritas group, which is a large multinational company that deals with test, inspection, and certification. So very happy to be member of the Bureau Veritas group. My name, if you did not recognize me, is Ralph Monen. I am the technical director here at Secura, and with me is Roy. Roy, maybe you can give a quick brief introduction of yourself, and then take it from there. So we'll be going on until 11:30 about. There will be opportunity to ask questions. You can also, if you have a question during the presentation, put it in the question box and we will answer those questions during the Q&A session. And at the end, there is also a survey, so please hang on and fill that out after the webinar. So Roy, welcome. Thank you for joining us today.
Thank you for your introduction.
What are you going to talk about today?
Today, well, the third part of the cloud webinar, so that's container security.
So what are containers?
Containers, well, we have slides for that, of course.
Ah, great.
Yes. So first this is a bit of the agenda for today. So first, a recap of the webinars that are already done in this series by my colleague Ricardo. And then we will dive into the topic of what are containers, why they are here, and why do we think that they will stay for a long time, and also the security challenges and considerations that exist when using containers, and especially when using them in the cloud.
Right.
And then we will end with the conclusions and, of course, some time for questions. Yes. So first, the recap of the previous sessions, a few of the main points that were told. When using the cloud, it requires a different way of thinking. It's different from using your on-premise or traditional servers, and it requires specific knowledge, and it comes also with unique challenges in those cloud environments. To move to the cloud, if your company wants to migrate to the cloud, there are multiple strategies. You can do it with lift and shift. You can also start using cloud native services. And when talking about pen testing the cloud or doing security assessments in the cloud, there are also different strategies which range from baseline checks to also doing privilege escalation techniques. We've also talked about that the cloud can give you a false sense of security. You still have to configure a lot of things in the cloud. You still have to make sure that your data is protected, because by default, it can be protected, but it might not be as secure as you think it is. and there's a lot more to configure, so make sure that you have the knowledge to do so. However, if all those risks are addressed and you work with the correct people, then using the cloud for a business can have a great potential. So today we talk about container security. Well, why container security? Wolf already talked about this a little bit. The cloud offers various services that use containers, and we see with our clients more and more container usage in production workloads. And that's why we want to talk about using the containers and using them safely. So what are these containers and why are they here to stay? Before talking about what are containers, I would like to ask you if you are currently using containers. Please fill in the poll that will be started. And give a few seconds to answer the question. Yes, I think that should be enough. Nice. We see that 42% is using it for production workloads. For non-production workloads, a few are only using it for garbage. That's always good.
Yep.
Some are not planning yet, but I see that most people are either using them or are planning to use it. So that's nice. Cool. So then the next question. If you use containers or plan to use containers, which platform do you use or do you plan to use? And that can either be like the self-hosted variant, it can be a cloud-based variant, it can be Kubernetes, or it can be any other variant like a Clico.
Yep, and if you're indeed using it just for garbage to keep the workplace clean, then all closed. Yep, there we go.
Yes, there we go. That's some nice results. A few Kubernetes, that's nice. Most of them are using cloud-based container services. Yes, that's what we like. And a few self-hosted. Awesome. Okay, then let's continue. So what is a container? For those of you who might not know yet, basically a container is an abstraction in the application layer. It abstracts and basically makes an archive of all the code and dependencies that are required to run your application. And by doing this, it requires less resources than a virtual machine. And those archives, called container images, they are very easy to distribute. Using containers, you can put multiple containers on one machine, hosting several containers. All of them are isolated processes, so you can also run different applications on the same machine in different containers. And the idea behind containers is that if you have a specific workload, you pull it apart basically and make it into smaller processes. And then using containers, you can also scale that individually. To compare the containers to virtual machines, well, there is difference. Of course, when using virtual machines, you have to create an entire guest operating system and allocate resources to that guest operating system before you can run your application. When using containers, this is not the case. You have a container runtime, which can be Docker or any other, that runs on top of your host operating system. And on top of that, you put all the containers, and so there are your applications. The thing is that the code runs on the host operating system when using containers. So if vulnerability exists, if you can escape the container, it has more consequences because then you might be able to interact with the host operating system. Whereas in virtual machines, you are still in the guest operating system. There was some research released from Forrester, and they claimed, well, the results show that containers are the heart of cloud-native business transformations, and that top priority IT leaders are using containers more and more. And this was also confirmed with another research from Red Hat that also said that, well, 65% of the companies, they basically use containers already in production environments, and they also expect it to grow even more in the coming years. So if you want to start using containers, what do you need? What can you do? Well, first of all, you need a container runtime. The container runtime, I think the most well-known one is Docker, but we also, well, there are others like Cryo and Containerd, and you can host them either yourself, just put it on your local machine, on your laptop, install it in a server. You can also do it in the cloud, and you can do it by renting a virtual machine in the cloud or using cloud-native services. And of course, using these cloud-native services, they have their own pros and cons, which I will talk about later. If you use containers and you want to use it in production, then you might run into things that you want to automate certain processes that cannot be automated by default. And then pretty soon you will start learning about Kubernetes. And Kubernetes is the orchestration platform that can manage your entire container workloads. And it comes with a lot of automation, like scaling your workloads, automatic rollover updates. It will automatically restart the container if your process crashes. However, using Kubernetes, it does come with a steep learning curve for new users. So you will need a lot of knowledge and invest time in learning the platform before you can actually safely use it, especially in production. The Kubernetes platform is developed by Google, and Google also uses it internally to run their own services. And that also means that it's like hugely scalable. You can scale Kubernetes on massive machines and many machines. You create a cluster, you can put hundreds of servers inside the cluster, and you can also put them on multiple locations. If you use Kubernetes correctly, then it will provide additional security on top of using just regular containers. So using containers, using Kubernetes, there are various flavors that you can use. So you have the cloud native container services like ECS and Azure Container Instances. You can do the same for Kubernetes. So we have EKS, AKS, and GKE on Google Cloud. But you can also say, I want to do it on-premise. I just have my own data center, my own servers, and I want to install like Red Hat OpenShift or use Rancher to deploy Kubernetes. And if you're really into it and really like technical stuff, you can also do bare metal, plain vanilla Kubernetes deployments. You will have all the possibilities, but you will need a lot of technical knowledge about the platform.
So when you say that Kubernetes is an orchestration platform,
yes,
does that mean that it will automatically scale the workload and distribute it over various Docker instances so that you have a dynamic workload distribution throughout your cloud deployments?
Yes,
that is the idea.
Basically, huh? Yes. It does depend on what you want, because you specify in a configuration file what you want to run and how you want to run it.
Yeah.
And then Kubernetes takes care of all the rest. So if you say, I want to have 5 instances of an Nginx container, then Kubernetes by default will distribute that over the running clusters or the running nodes in the cluster.
Right. And so especially when workload varies a lot. Yeah. So for instance, in a lot of web type deployments, this would be a solution.
Yeah. Definitely, and Kubernetes also has the possibility that if a specific container suddenly gets a peak of traffic or a peak of CPU usage, it can actually pick up that container and move it to a node that has nothing to do. Right. So it will have more space to do its job, basically.
Okay, so it's also a load balancing mechanism. Right.
Yeah.
Right.
Yeah.
Excellent.
Yes, it's huge. So now we're talking about Kubernetes. I would like to ask, do you use it? And do you use it in production, or have you ever heard of it? Or do you use it in the cloud? Yes, let's look at the answers. A few are self-hosting it. Most are using it in the cloud. A few are planning to, and a few are not planning to yet. Well, maybe after this webinar, you will have a look at it and maybe you change your mind. Okay, so let's talk about containers as a service. So running containers in the cloud and what the benefits of that are. If you run containers as a service in the cloud, it hides all the underlying infrastructure. So you don't have to worry about updating your machines and patching it or maintaining the network. It's basically you say to the cloud provider, this is my image I want to run. This is how I want to run it with this network configuration. And that's it. It will all be taken care of. So there's no need to set up and maintain any container hosting infrastructure. It is relatively simple and fast. I mean, you can deploy your containers in a few minutes, within a few minutes. And of course, the configuration that you set up, that is determining how secure it is or not. Because you can configure the networking connectivity of that container. And of course, if you set everything to public whilst it's an internal and private application, you might have some security risks. Basically, the same story holds for Kubernetes. If you use Kubernetes as a service, we say it a one-click cluster configuration. If you ever went to the process of setting up Kubernetes yourself, you need multiple steps, you need some debugging, and you need a lot of maintenance when it's running. If you do it in the cloud, you say, I want this setup, I want this many nodes, I want it this big. You click a button, you wait a few minutes, and you have your cluster. And the main advantage of using this in the cloud is that the master nodes, so basically the servers that are hosting the management of the entire cluster, they are hidden. You cannot see them, and the cloud fully manages that part of the cluster. So they make sure that your master nodes, that they are highly available, that they are redundant, so that if one goes down, not your entire cluster goes down. Again, with everything in the cloud, configuration is key. You can make misconfigurations which make it insecure. So it's important to have the specific knowledge that you need to deploy these resources in the cloud. So let's move on to some of the security challenges and the considerations that you have to keep in mind when you're using containers or Kubernetes in the cloud. And first, in high level, what can go wrong if you're using these technologies? Well, of course, as with anything, using unpatched versions, outdated versions of the container runtime or Kubernetes, which might have known vulnerabilities, an attacker can abuse them. If you're using images from public resources or public sources, then they might contain vulnerable software because it might be outdated. So make sure to check that you're always using the latest version and that it's also updated, not only the software you're using, but also any dependencies that it needs. Then we have the backdoored containers. That's a really nasty one. Mm-hmm. I would say you want to use an application, you start Googling around, and then you find a Docker image or container image. Hey, that's the application I want, and it's easy to set up. But it's an untrusted source, and if you don't do enough research, you might just use it and not know that someone placed a backdoor inside. So an attacker can remotely get a shell inside your container or run some commands or injected some malicious code in the application that sends data to an attacker server.
How would you discover such a backdoored container? If you download something from the internet and you think, okay, well, I won't deploy this in production before I've checked this. Is this something that you can do?
Yeah. I would do network analysis. Mm-hmm. Because you know that if something malicious is inside, it will probably try to either let a connection come in, mm-hmm. for instance, for a shell.
Okay, but you can see that quite easily.
Yeah, mm-hmm. Or send data out which you do not expect.
Right.
And always, if you use an application, and also always in containers, you have to specify the networking part, so you have to specify which ports are open. If you see something strange, and for instance, you're using a web application and you see that it needs port 22 open, yeah, you know, mm-hmm. something fishy is going on.
Yeah. Excellent. Thank you.
What else can go wrong? Well, publicly exposing those administrative endpoints, and also, like I mentioned before, configuration is key. Misconfigurations happen, especially in cloud environments, because it all looks very easy and the default configurations might not be secure. And for an attacker, they try to get access to the container, and once they get access to that container, they try to either extract data from it or escape the contained environment and then pivot to the host operating system and then either pivot further into the cloud environment or on-premise. So when talking about exposure, of course, it's really easy to say critical components should not be exposed to the internet. What are those critical components? Well, a few are mentioned here. Those are the container images that you use privately, so you develop them internally. You do not want them to be publicly on a registry where everyone can download them. The same holds for internal applications, for APIs like the Kubernetes API, which actually manages the entire cluster. But also if you're using Docker, the Docker socket or the Docker TCP socket that is used to control the Docker environment, you do not want to have that publicly exposed. If you use cloud services, they will hide a few of these things. But for instance, when you use a cloud Kubernetes instance, you can still say, I want my Kubernetes API to be reachable from every IP address. And that's something we would not recommend. The principle of least privilege, you probably heard of that multiple times. It's pretty well known within the security world. This also applies to using Kubernetes and containers. So you do not want to run your applications as the root user inside that container. It's the same as installing Nginx or Apache on your web server and installing it with root privileges. You do not want to do that. If something goes wrong, if an attacker can take over or get remote code execution, he will have all privileges inside that container, which help a lot when trying to escape. The same holds for adding additional permissions or capabilities to containers. You can add capabilities to a container that give access to specific system calls on the host. If you give them the wrong capabilities, for instance, the sys module capability, then if an attacker gets a remote code execution, it is possible to get a reverse shell as root on the host file system. And that's a pretty nice attack to do. Mm-hmm. We did it a few times with clients as well, and they were amazed.
sounds dangerous. So I think that sometimes it would be necessary though to add extra capabilities. Yeah. So when you have to do this, is there any precaution that you can take?
Well, provide as the least privilege possible, mm-hmm. And closely monitor anything that is happening. If you need specific capabilities or running privileged containers, make sure they are not tied to the internet. They are like isolated on themselves, mm-hmm. And you have monitoring and also active alerts that give you an email and notification if anything goes on that's not expected.
Right. Okay, thanks.
Yes, and also, especially when using cloud resources, you have to deal with giving permissions to read or even write on Kubernetes or container resources. Limit the amount of users that can do this. This limits the attack surface because all these users, they can be phished or they can become malicious within your company, and you just want to limit this risk. When you're using the cloud, they have several offerings that help you restrict this access. So for instance, if you have your own container images, you can use private image registries. They are not tied to the internet, and only you or only the Kubernetes cluster that's also running in that cloud environment can use the images from that registry. And of course, in the cloud, you have quite a lot of network limitations at your hand, so you can configure firewalls and network security groups to limit all the traffic that is not necessary. An important thing that, well, sometimes gets forgotten is that the non-cloud best practices, they are still valid. So you want to also pen test the application itself before putting it in a container, because putting a vulnerable application inside a container will not make it secure. it will still be vulnerable for the same things as when you put it on a traditional server. You want to have trusted base images that you use. So for instance, you start building your image from Alpine or Ubuntu or Nginx, use a trusted image. So if you Google around for Docker images or container images, you find probably you will come to Docker Hub, which is a pretty well-known registry. There are verified publishers over there. Please use them and don't use some account from some unknown person, because you do not know what's inside. And what you can do is to scan the containers that you use and the images that you use, for instance, using Clear or SNCC. And what that will do is that it will scan your container for known vulnerabilities, for instance, the dependencies that it uses, if they are outdated. And of course, when you're using cloud, they have a lot of configurations and services that can help with all of the above. Talking about architecture and also network architecture, using containers and especially Kubernetes, there are some specifics. It's very important to know that by default, when you're using Kubernetes, any deployment that you make, so any container that you deploy, they have unrestricted network communications to any other container or service inside the Kubernetes cluster. That means that if you do not restrict this and an attacker can compromise that container, he will not have any limitations to jump to other containers. And you do want to restrict that, of course. And Kubernetes also has some things that you can do against that, so implementing network policies and using namespaces for different applications. However, know that namespaces are not isolating the resources on a network level by default. You still need a network policy to restrict that traffic. And then what you can also do when you're using the Docker or Kubernetes, have a look at the security benchmarks that are present. So we have the sys Docker benchmark, the sys Kubernetes benchmark, which is also available in the different cloud flavors. And I think a few months ago, the NSA released the Kubernetes hardening guide, which also contains a lot of recommendations that you can have a look at when you're using this technology. This does give a basic of security, but do note that, well, you can be compliant, but that does not automatically mean you're fully secure. Like I said, you can be compliant with this NSA Kubernetes hardening guide, but if you deploy a vulnerable application, an attacker might still come in. I have a few notes about testing containers. We at Secura do quite a lot of testing containers and Kubernetes environments. And basically, well, what do we look for? What is the thing that you can have a look at when you're using it and want to know if you're secure or not? Well, first thing we usually look at is looking at the container capabilities. Are capabilities added that allow for some escape path or privilege escalation path? Do we have unrestricted network access? Can we scan every cluster or every container inside the Kubernetes cluster? Can we maybe reach internal IP addresses from the on-premise network? And of course, especially when hosting applications, are there any secrets inside the container? So are there user credentials, are there database credentials? And can we then connect to that database? And when we're using Kubernetes, by default, they get a service account, and with that service account, you can authenticate to the API and query the API. And if the permissions are not set up properly, you might be able to pivot further into the cluster to other workloads. So some of the examples of assessments we did, some of them we start with a compromised container or compromised pod scenario with the goal to break out of the container or to pivot further into the cluster or the on-premise network. So we assume that the attacker already got a remote code execution in the application, and we start from that point. We try to do software extraction from a container, and what we can also do is a benchmark review. So we run some scanning tools to see if your environment upholds to the CIS benchmark or the NSA benchmark. So the next steps, basically the conclusions from this webinar. The containers are here to stay. We see an increase of usage, non-production, but also in production. The cloud services, they help you a lot in deploying and managing these container deployments, which can be more secure. But the configuration in the end defines how secure or insecure you are. And we truly recommend to have a security professional look at your configurations and look at your environment before putting it into production. Of course, the non-cloud security principles are still valid, so also have your application tested separately, and you can use the baseline checks to get a basic of security. So that's the CIS Docker benchmark, the NSA Kubernetes hardening guide, and you can use scanning tools to do that. Basically, this is the conclusions of this webinar. We now have some time for questions.
All right. Thank you, Roy.
Yes. Thank you.
Well, I'll give you a question right off the bat, because I was wondering, when you distribute containers, shouldn't you also make sure then that there are no secrets in the containers at that moment? Because I've heard of cases where people have uploaded their Docker container to some internet site to distribute it, and API keys and database passwords were still in there. Yeah,
definitely. Yes, do not do that. Please don't. No, there are different ways of doing that. If you're using the cloud, one of the most common ways is to use a secrets manager, or use like the Azure Key Vaults to put your secrets in and let your application query that key vault. And then you might be thinking, okay, but how do I get permissions to query that key vault? Well, you're running it on the cloud. So in your cloud portal, you can configure that container to have the permissions on a specific key vault.
Okay. So basically it is store those secrets outside of the container.
Yes. Definitely.
Right.
Everything,
but maybe not on your host operating system then, because then you have to add extra capabilities to get those keys out.
That's true. No. The thing is, everything you put inside a Docker image, that can be extracted.
Right.
So that can be software, that can be secrets, that can be anything. And also know that if you use an installation script and you copy that in one of the early files of building your image, and then you run that script and then you remove it, then you think, hey, it's gone. So I'm cool, I'm secure, it's safe. The secrets that were in that script, they are gone. No, you can extract every layer of that image, and you can extract that script of your Docker image.
Okay, so we have a question from Christoffel. What is the most remarkable that you've noticed at a customer? Was there any notable misconfiguration or weird situation with containers?
Yeah, I think I have two stories, to be honest. One was quite recent, that with a client that actually we did a compromised pod scenario. So we went in as being the application was compromised, and we found in the configuration file that there were access keys for their cloud environment. And from there on, we moved further.
For their full cloud environment.
Yes, their full cloud environment. Yeah. So first things first, we called the client and of course asked, why do you need these? Why are they here? There was no clear answer on that. But in the end, those cloud keys, yes, you could do some nasty stuff.
Okay.
You had a lot of permissions on the cloud environment, and you had all the permissions you need to basically manage their entire user pool on the cloud.
Wow.
Yeah, that was pretty nice.
And the second one?
The second one was a Kubernetes assessment. We found a few privileged pods that were deployed, and well, basically privileged pods means add all the capabilities that you have. So from that we escaped to the host, and so you're on the node, on the server, on the actual server, and there we found a kubeconfig file, and that the kubeconfig file is basically the file you use to connect to the Kubernetes API. That's your authentication file, so to say. So we found that, and we were thinking, okay, why is this on the node, and which permissions do we have? So let's try. Can we list all the pods? Yes, we can. Okay, so we have some read access. Can we execute commands inside pods? Yes, we can. Okay, so we also have write access. Can we deploy pods? Yes, we can. So in the end, we enumerated the permissions, and we found out that it actually gave us full cluster admin permissions. So that was a really nice one. And from there, of course, we are not malicious, but if we were malicious, then we could basically destroy everything.
Yeah.
Or like run some ransomware or crypto mining or whatever.
Have you ever seen, a deployment where it was done correctly, where you found nothing wrong?
Actually, yes. Well, of course, there are always a few things that have a trade-off. Like we can recommend to enable certain settings, but it has a trade-off of usability. But I think we had one customer using Red Hat OpenShift, and that's a flavor of Kubernetes, but it's pretty secure by default.
Okay.
So if you just use the default configurations, it is secure. You cannot just deploy privileged pods. It's all limited.
Right.
And to be honest, we looked around, I think, for 3 or 4 days inside that environment. We didn't find much.
Okay.
There were, of course, some remarks and some findings, but not that much.
Excellent. Okay, we have another question come in. What are no regret security measures?
No regret security measures.
Well, I guess what they mean is no-brainers, stuff that you will not regret doing.
Oh,
so stuff that you should always do, basically.
What you always want to do in Kubernetes, put up a network policy or global network policy to restrict all traffic by default, and then start opening things up if you need it.
Right, but this is not really different from traditional application architecture, right?
No, it's not. But you need to think about it.
Right.
It's and also a no-brainer. We noticed that a few clients think, oh, I have my application, let's put it in a container and it's secure.
Yeah. No. Yeah, I've heard customers also say, well, it runs in a Docker container now, it must be secure.
Yeah.
But yeah, it's maybe good to stress that Docker technology is not a security technology.
Exactly. And also, what else do we have? Do not use privileged containers unless you really need to. But often we see that in debugging, when you start using containers, you run into some issues like, hey, it doesn't work. Maybe it's permission related, and then they just add privilege, so add all permissions, and then in the end they forget to remove it.
Right.
And then you have a privileged container running in production, which has a huge security risk.
Yeah. Well, actually, some time ago, we were preparing some challenges for a CTF. So I was tasked to build a vulnerable Docker and to build a Docker escape challenge. So it took me a while to figure out, but to make one that was, actually reproducible very reliably. Yeah. But it wasn't that difficult. So it that showed to me that it's actually quite easy also to make mistakes that have consequences. So especially those capabilities, because there's more than just a few that can be assigned that have consequences.
Yeah, definitely. I think we have our Docker training course. We have a few labs. I think it's 4 labs, which you will use the privilege and the capabilities to escape the container. Actually,
right. Is there any new course planned yet?
Yeah, I think we have one in January that's planned. Yes.
Okay.
Yeah, and that will be Docker and Kubernetes.
Okay.
Yeah, cool. And we have some nice labs for that.
Excellent. Great, thank you. There's no more questions currently, so I think we will round it off here. So cool. Everyone, thank you for your attendance. If you do have some more questions, please don't hesitate to put them in the question box. We will answer them after the webinar by email. Also, there is the survey. Exactly, thank you. Please don't forget to fill it out. And well, this was actually the last installment in our cloud security series. So
that's true.
Thank you, Roy.
Yeah, thank you.
I hope to see everyone in our following webinars in the future. Thank you very much.
Thank you.